Have you ever wondered how light bulbs work? These everyday objects are so common that we often take them for granted, but the science behind them is truly fascinating. Or why fireflies glow in the dark. These tiny creatures light up the night with a magical glow that has intrigued humans for centuries. The answer lies in the fascinating world of light production, where two main contenders battle it out: incandescence and luminescence. Incandescence is the process that powers our traditional light bulbs, while luminescence is the secret behind the firefly's glow. These two phenomena illuminate our world in different ways, each with its unique story to tell. Incandescence involves heating a material until it glows, while luminescence involves a chemical reaction that produces light without heat. Join me as we explore the captivating realm of light, uncovering the secrets behind these illuminating processes. We'll delve into the history, the science, and the incredible applications of both incandescence and luminescence. From the warm glow of a traditional light bulb to the cool light of a firefly, each type of light has its own charm and utility. Traditional light bulbs have been lighting our homes for over a century, while fireflies have been enchanting us for millennia. We'll uncover the science behind these everyday wonders. How does a light bulb convert electricity into light? How do fireflies produce light through bioluminescence? These questions and more will be answered. Get ready to be enlightened as we delve into the captivating showdown between luminescence and incandescence. Whether you're a science enthusiast or just curious about the world around you, this journey into the world of light is sure to illuminate your mind. Let's start with incandescence, the more familiar of the two. Think of a traditional light bulb with its glowing filament. That, my friends, is incandescence in action. Incandescence is all about generating light through heat. When you heat something up, its atoms get excited and start to vibrate rapidly. This excess energy needs an escape route, and guess what? It's released in the form of light. The hotter the object gets, the more its atoms vibrate, and the brighter the light it emits. Pretty straightforward, right? Now let's take a closer look at what's happening inside that glowing light bulb. The filament, typically made of tungsten, is designed to withstand incredibly high temperatures. When electricity flows through it, the filament heats up rapidly due to its electrical resistance. As the temperature soars, the atoms within the filament become energized and release their excess energy as light. This light, a mixture of different wavelengths, appears white to our eyes. However, a significant portion of the energy is also emitted as heat, which is why incandescent bulbs get so hot. Now let's shift gears to luminescence, the cooler cousin of incandescence. Unlike incandescence, which relies on heat, luminescence occurs when an object emits light without getting hot. Think of fireflies, glow sticks, or even the screen you're reading this on. They all produce light through luminescence. But how does luminescence work its magic? It all boils down to electrons, those tiny charged particles that zip around atoms. When an electron absorbs energy, it jumps to a higher energy level. But just like a ball rolling uphill eventually rolls back down, the excited electron wants to return to its original lower energy state. Section 5. Exploring different types of luminescence. Luminescence is a fascinating phenomenon where light is emitted by a substance without the need for heat. This can occur in various ways, each with its own unique mechanism and application. Just like there are different ways to cook an egg, there are various ways to excite electrons and produce luminescence. For instance, you can boil, fry, or scramble an egg, each method yielding a different result. Similarly, the excitation of electrons can be achieved through different processes, leading to various types of luminescence. One common method is through chemical reactions, like in glow sticks, where mixing chemicals triggers a reaction that releases energy as light. This type of luminescence is known as chemiluminescence. When the chemicals inside a glow stick are combined, they undergo a reaction that excites the electrons, causing them to emit light as they return to their ground state. Another way is through a process called electroluminescence, which is how LEDs and OLED screens work. In this process, an electric current is passed through a material, usually a semiconductor, which then emits light. This is the principle behind many modern lighting and display technologies, making it a crucial component of our daily lives. In electroluminescence, electricity excites electrons in a semiconductor material, causing them to release light. This process is highly efficient and can produce a wide range of colors, which is why it is used in everything from household lighting to high-definition television screens. The ability to control the color and intensity of the light makes electroluminescence incredibly versatile. And then there's bioluminescence, the fascinating ability of living organisms like fireflies and some deep-sea creatures to produce their own light through specialized chemical reactions within their bodies. This natural form of luminescence is not only beautiful but also serves various purposes, such as attracting mates, deterring predators, and luring prey. The study of bioluminescence has even led to scientific advancements, including the development of new medical imaging techniques and the creation of bio-inspired lighting solutions. Section 6. Efficiency Face-Off: Incandescence versus Luminescence. Now let's talk efficiency. When we discuss lighting, efficiency is a key factor. It's not just about how bright a light is, but how much energy it uses to produce that brightness. This is where the battle between incandescence and luminescence gets interesting. When it comes to lighting up our world, we want to do it in the most energy-efficient way possible. Think about all the places we use light: our homes, streets, offices, and even in our gadgets. The demand for efficient lighting is everywhere, and in this arena, luminescence emerges as the clear winner. Luminescent light sources, like LEDs, have revolutionized the way we think about lighting. They are not only brighter, but also consume far less energy compared to their incandescent counterparts. Remember how incandescent bulbs get really hot? This heat is a clear indicator of inefficiency. The energy that could be used to produce light is instead wasted as heat, making these bulbs less efficient. That's because they waste a significant amount of energy as heat, instead of converting it into visible light. This not only makes them less efficient but also means they have a shorter lifespan due to the excessive heat they generate. Luminescent sources, on the other hand, are much more efficient. They produce minimal heat, which means more of the energy they consume is converted into light. This efficiency translates to longer-lasting bulbs and lower energy consumption. They convert a higher percentage of energy into light, resulting in less wasted energy and lower electricity bills. This is particularly important in a world where energy conservation is becoming increasingly critical. This is why LEDs, a type of luminescent light source, have become increasingly popular in recent years. They offer a sustainable and cost-effective solution for our lighting needs, making them the go-to choice for both residential and commercial applications. As technology advances, we can expect luminescent lighting to become even more efficient and widespread. Section 7. Everyday Examples. Spotting the difference. So, how can you tell the difference between incandescence and luminescence in your everyday life? Look for the heat. If an object is producing light and feels hot to the touch, like a traditional light bulb or a burning candle, it's incandescence at work. If the object is producing light but remains cool, like a glow stick, a firefly, or your smartphone screen, it's luminescence doing its magic. By paying attention to these subtle clues, you can start to appreciate the different ways light is generated all around us. Section 8. The Science Behind the Shine, a Microscopic View. To truly understand the difference between incandescence and luminescence, we need to zoom in to the atomic level. Imagine atoms as tiny balls constantly jiggling and vibrating. In incandescence, heat makes these atoms go wild, vibrating with such intensity that they emit light. In luminescence, however, the atoms are more like skilled dancers, absorbing energy and then releasing it as light in a controlled manner. This difference in atomic behavior is what gives luminescence its cool glow and higher efficiency, compared to its hotter counterpart. Section 9. The Future of Light, Embracing Efficiency and Beyond. As we continue to explore the fascinating world of light, one thing is clear: luminescence is the future of illumination. Its energy efficiency, versatility, and cool glow make it the ideal choice for a wide range of applications, from lighting our homes and cities to powering our electronic devices. And as scientists and engineers continue to push the boundaries of luminescent materials and technologies, we can expect even more innovative and efficient lighting solutions in the years to come. So, let's embrace the cool glow of luminescence and illuminate our world in a smarter, more sustainable way.